Welcome to Westel's Passive Components for Inquiring Minds. In this episode, we will discuss power dividers. What are power dividers and what are they used for? Power dividers are devices that take one input signal and split it into two or more outputs. Typically, a signal from a bidirectional amplifier, BDA, enters the power divider's input, and the device then distributes the signal to multiple outputs. So why do we split the input power? A BDA has only one output, but a distributed antenna system, DAS, can have many antennas. Power dividers allow us to connect the single output from a BDA to multiple antennas. Shown is the single output of the BDA entering a two-way power divider. From there, each output connects to a three-way power divider to feed a total of 6 antennas. While we also use other components like tappers and directional couplers, we'll save those devices for another day. Keep in mind that splitting the signal does result in a loss of power. For example, in a two-way power divider, each output will carry half the power of the input. Similarly, a three-way divider distributes 1/3 of the input power to each output, and a four-way divider splits it into quarters. In addition to this splitter loss, there is also insertion loss, which is an additional loss caused by the internal components of the power divider. In a DAS, power dividers also function as combiners. Signals from multiple portable handsets communicating to different antennas are combined before being sent to the BDA. The same splitter and insertion losses apply in this direction as well. Westel offers two types of power dividers, each with distinct attributes, Wilkinson and reactive. Let's compare these two as two-way power dividers. Both types share a single input and two outputs, but that is where the similarities end. The Wilkinson power divider features a more compact design, making it easier to fit into most junction boxes, J-boxes. In contrast, reactive power dividers are larger and require bigger J-boxes. Add a minimum bending radius to the attached cables, and this enclosure can get quite large. Every passive component has a maximum power rating, and this is where the reactive power divider excels. It is rated for 300 watts at the input, while the Wilkinson is limited to 50 watts. However, public safety BDAs are usually capped at 5 watts, so both types should be able to handle the power requirements without issue. Insertion loss is another area where the reactive power divider holds an advantage. It typically incurs a loss of a couple of tenths of a dB less than the Wilkinson. While this may seem minor, those tenths can accumulate in larger systems. It's also important to consider the frequency range for which these devices are operational. The Wilkinson can accommodate all 4 public safety bands: VHF, UHF, 700 MHz, and 800 MHz. However, this specific reactive power divider does not support VHF but can handle the other 3 bands. Always check the specifications of the specific power divider to ensure it meets the frequency requirements. Power dividers can be used as combiners, which might tempt users to combine the outputs of 2 BDAs operating on different bands. For example, the fire department may use UHF, while law enforcement uses 800 MHz. By combining the BDA outputs, you could have one antenna system instead of separate ones for each band. However, the reactive power divider is not suitable for this purpose. There is insufficient isolation between the two output ports when they are used as inputs. If a high-powered signal from one BDA enters this port, a significant amount of power will leak out through the second port, leading to various issues that should be avoided. The Wilkinson power divider, in contrast, provides much better isolation. However, when its output ports are used as inputs, the power rating for those ports may drop to a tenth of the normal input rating. So if the Wilkinson is rated at 50 watts, each output port would only handle 5 watts in this scenario. In reality, there are passive components specifically designed for this purpose, such as hybrid combiners and crossband couplers. We'll cover those in a future episode. Finally, consider the costs of these units along with their physical and electrical characteristics. The reactive power divider often has a significant cost advantage. It can be priced around 1/3 less than the Wilkinson. This clear differentiation should help you better understand the role and applications of power dividers in an antenna distribution system.